Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 2nd, 2025, just yesterday. It presents an open large language model that uses efficient sparse attention, scaled reinforcement learning, and massive agent-style training to match GPT-5 on many tasks, while a high compute variant even surpasses GPT-5 and reaches gold medal performance in the 2025 International Math and Informatics Olympiads. The paper is titled DeepSeek-V3.2, Pushing the Frontier of Open Large Language Models. And, as we will see later, the combination of efficiency and contest-level reasoning has some really striking implications for how we train future models. Figure 1 shows how DeepSeek-V3.2 stacks up against top proprietary models on reasoning and agent-style tasks. Pass at 1 means the model must get the answer right on its very first try, which is a strict exam-style metric. The left half of the chart shows that both DeepSeek variants match or beat GPT-5 high on math, logic, and Codeforce's programming rating. The right half shows strong agent performance, where the high compute specialty model reaches or exceeds the best closed models on software engineering, terminal usage, and complex multi-tool benchmarks. Figure 2 spells out how DeepSeek sparse attention routes information, so each token only attends to the most relevant past tokens. The central band shows the usual multi-query attention core, which still computes detailed interactions once candidates are chosen. On the left, the model forms queries from the input hidden state. On the right, the green lightning indexer and top K selector score earlier tokens and pass only the best few into the core attention, which saves computation on long contexts. Figure 3 makes the efficiency story concrete, because it shows that DeepSeek V3.2 is dramatically cheaper to run than DeepSeek V3.1 Terminus as sequences get long. The full figure plots cost per million tokens on real H800 clusters at a fixed rental price. The left prefilling panel shows the old dense model cost rising steeply with token position, while the sparse model line stays low and almost flat. The right decoding panel tells the same story, with an even larger gap at 128,000 tokens, which means long chats or documents cost far less to serve. Table 1 spells out what kinds of agent tasks the model actually trains on, which shows how broad the agent-style reinforcement learning really is. The table as a whole lists 4 task families with their scale: environment realism and prompt origin. The header row defines number of tasks, environment type, and whether prompts come from real data or synthetic generation. The body rows then separate code agents, search agents, general agents, and code interpreters, with tens of thousands of real tool calls anchoring the training distribution. Alright, wrapping up, 2 takeaways stand out. DeepSeek V3.2 shows that clever sparse attention, plus serious reinforcement learning, can make an open model both cheap to run and competitive with GPT-5 level reasoning, and broad agent training turns that raw intelligence into practical tool use. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.